Hello, my name is Zamirul. Today I'm going to talk about the development in astronomy throughout the years, specifically the historical development of the solar system models. First thing first, we have to learn about the solar system models. This presentation explores the evolution of solar system models from geocentrism to heliocentrism. We will examine the contributions of key figures such as Ptolemy, Copernicus, and Kepler. The first person on this list is Ptolemy. Even though Aristotle developed the fundamentals of Greek geocentrism, his system specifics were never codified. Geocentrism was eventually standardized by the Ptolemaic system, which was created in the 2nd century AD. But the principal work on astronomy was the result of centuries' effort by the Babylonian, Hellenistic, and Hellenic astronomers. It was the accepted cosmology model among European and Islamic astronomers for more than a millennium. Owing to its influence, people may mistakenly believe that the geocentric model and the Ptolemaic system are the same, based on the straightforward finding that half of the stars were above and half below the horizon at Ptolemy postulated that the Earth was a sphere at the center of the universe. Secondly, we have Copernicus. Copernicus' major work, De Revolutionibus Orbium Celestium, on the revolutions of the heavenly spheres, was a compendium of 6 books published during the year of his death, though he had arrived at his theory several decades earlier. The work marks the beginning of the shift away geocentric and anthropocentric universe with the Earth at its center. Copernicus held that the Earth is another planet revolving around the fixed sun once a year and turning on its axis once a day. But while Copernicus put the sun at the center of the celestial spheres, he did not put it at the exact center of the universe, but near it. Copernicus' system used only uniform circular motions, correcting what was seen by many as the chief negligence in Ptolemy's system. Besides that, the Copernican model replaced Ptolemy's equant circles with more epicycles. 1500 years of Ptolemy's model helped create a more accurate estimate of the planet motions for Copernicus. This is the main reason that Copernicus' system had even more epicycles than Ptolemy's. The more epicycles proved to have more accurate measurements of how the planets were truly positioned. Although not enough to get excited about, the Copernican system can be summarized in several propositions, as Copernicus himself did in his early commentaries that he handed only to his friends, probably in the 1510s. The little commentary was never printed. Its existence was only known indirectly until a copy was discovered in Stockholm around 1880s, and another in Vienna a few years later. Lastly, we have Kepler. He published his first 2 laws about planetary motion in 1609, having found them by analyzing the astronomical observations of the Tyro bark. Kepler's third law was published in 1619. Kepler had believed in the Copernican model of the solar system, which called for circular orbits, but he could not reconcile Barks's highly precise observations with a circular fit to Mars' orbit. Mars, coincidentally, having the highest eccentricity of all planets except Mercury. For his first law reflected this discovery. In 1621, Kepler noted that his third law applies to the fourth brightest moons on Jupiter. Godefroy Wendelin also made his observations in 1643. The second law, in the area law form, was contested by Nicolas Mercator in, in a book from 1664, but by 1670s, his philosophical transactions were in its favor. As the century proceeded, it became more widely accepted. The reception in Germany changed noticeably when 1688, the year in which Newton's Principle was published and was taken to be basically Copernican, and the 1690s, which by the time work of Gottfried Leibniz on Kepler had been published. Lastly, Newton was credited with the understanding that the second law is not special to the inverse square law of gravitation, being a consequence of the radial nature of the law, whereas the other laws do depend on the inverse square form of the attraction. Carl Repunge and Wilhelm Lenz much later identified a symmetry principle in the phase space of planetary motion in the orthogon group O4 acting, which accounts for the first and third in the case of Newtonian gravitation, as conservation of angular momentum does via rotational symmetry for the second law. As we are in the near end of the video, I'm going to talk about the Kepler's law. There are three laws. The first law is that the orbit of a planet is an ellipse with the sun at one of the 2 foot two foci. Next, on the second law, it is a line segment joining a planet and the sun sweeps out equal areas during equal intervals of time. And lastly, the third law. The square of a planet's orbital period is proportional to the cube of the length of the semi-major axis of its orbit. As we are reached the end of the video, thank you for listening to everything I said. Please subscribe and like. Goodbye.